Welcome back in this special series of System Verilog Assertion. In the last video, we had a discussion about the implication operators with respect to this SVA. Over there, we discussed same cycle and next cycle implication operators. Now, in this video, I will be talking about the concept of implication with a sequence and timing window. So, as you can see over here on the screen, how we can define implication operator if we have defined some sequences. Okay, let's try to understand that first. So this is what a sample assertion code. In the sequence definition as well, I'm writing if A is high, after delay of 1 clock cycle, B should be high. In the sequence S2, I'm writing after delay of 1 clock cycle, C should be high. Okay. And in the property definition, property P1, A property, at every passage of the clock, S1, which is referred as a implication, which is referred as an antecedent, if it is there in the same cycle, S2 should be there. Okay, so what is S1? In S1, we are defining A is high after delay of 1, B should be high. Okay, and what is S2? This S2 is nothing but after delay of 1 clock cycle, C should be high. Okay, so as you know, I hope you remember in the last video, I told you that the left hand side of this implication is referred as an antecedent. Okay. And the right hand side of this implication operator is referred as a consequent. Okay. And this antecedent is nothing but a gating condition. If the antecedent succeeds, then the consequent is evaluated. Okay, remember this. Then we are asserting this property P1, in which we are writing our own custom message, which is nothing but the action block. Over there, we are writing if the assertion is passed, then we are printing the time and we are writing the message property P1 succeed. Else, we are writing the property P1 fail. Okay, let's try to understand with the help of this waveform. Okay, so at this passage of the clock, you will find A is high, hence the assertion is starts over here. In the next clock cycle, B is low, right? It means the antecedent itself is not passing. Even though the antecedent is not passing, will not get any fail message over here. Why? Because while we are using the implication operator, whenever the antecedent itself is not passing, it is referred as a vacuous success. Okay. Hence, try to understand at this passage of the clock. At this passage of the clock, A is high. Okay. And the next passage of the clock, the B is low. Okay. Then also we are not getting any error messages. Let's try to understand at this passage of the clock. So at this passage of the clock, A is high. In the next passage of the clock, B is also high. Okay. It means the antecedent is passing. Hence you will find this yellow triangle. It means the antecedent passed. In the next clock cycle, as you can see, C is also high. Hence the assertion is passing. You will find the green triangle. Now at this passage of the clock, if you see A is high. In the next passage of the clock, B is also high. And in the next passage of the clock, the C is also high. Hence you will find the assertion is passing over. Now try to understand at this. Okay, let's try to understand the failing condition. Okay, at this passage of let's try to understand here. At this passage of the clock, A is high. In the next passage of the clock, B is also high. And in the next passage of the clock, the C is also high. You will find the assertion is passing over here. And you also find the, this green triangle and this square. Okay, this blue square over there, you'll find assertion is start. Here also assertion is starting means the value of A is high. In the next clock cycle, you will find B is also high. Hence, you will find the yellow triangle means the antecedent is passing. In the next clock cycle, you will find C is low. Okay, but we want C should be high here, right? Hence, we'll find the red triangle means antecedent is passing, but the consequent is not passing. Hence, you'll find the fail messages over here. If you analyze the waveform carefully, you'll find we'll get 4 succeeded messages and 2 failure messages over here. So if you see here also, you'll find 2 red triangle. It means 2 times assertion is failing. And if you see the assertion tab over there, you'll find 4 pass count and 2 failure count. So okay, so this is what we can use the implication operator for our sequence, and in the sequence we can define our logic or our Boolean expression. Now let's try to understand a very interesting topic, and it is like a timing window in system Verilog Assertions. Let's consider our protocol or our design says that if the signal A is high from the same clock cycle, B can be high within 1 to 3 clock cycles. Okay. For that, we can write the assertion in two ways. So first way is like in the property definition. At every passage of the clock, we can write if A is high from the same cycle. Okay, so we have to use same cycle implication operator. B can be high in 1 to 3 clock cycles. Okay, so B can be high in the next clock cycle, or B can be high after 2 clock cycle, or B can be high after 3 clock cycle. Okay, and then we are asserting the property, and over there we are writing if the assertion is passing, we are writing property P1 is succeeded, else the property P1 is failed. Similar to this, we can write the assertion for the same line, like property P1 at every passage of the clock, A is high in the same from the same clock cycle, hash hash within a square bracket, B can be high in next 1 to 3 clock cycles. The problem with this assertion, okay, while we are using hash hash B or operator hash hash 2B or hash hash 3B, let's say our protocol says that B can be high within next 1 to 100 clock cycle. The assertion become complex. We have to write that OR operator and hash hash operator multiple times. So for that, the simple solution here is we can use the square bracket over there. We can provide a range for the operator B. Okay, for this B variable. So it is very simple, right? Meaning, as you can see over here in the property P1 at every passage of the clock, whenever A is high in the same clock cycle, B can be high in next 1 to 3 clock cycle. Okay. And then we are asserting the property P1. Whenever the property is passed, we are writing our own custom message property P1 succeeded, else property P1 failed. Okay. Let's try to understand the waveform for this. So what our assertion says, our protocol says A is high from the same clock cycle, B can be high within 1 to 3 clock cycles. Okay. So for that, the waveform is like that. Here at this passage of the clock, you'll find A itself is low. Hence, it is referred as a vacuous successful up to this 3 passage of the clock. At this passage of the clock, A is high. B should be high in next 1 or 2 or 3 clock cycles. Okay, as you can see over here in the next clock cycle from the same cycle, in the next clock cycle, in the next 1 to 3 clock cycles, right? So at this clock cycle, you'll find the value of B is high. Hence, you'll find the green triangle. It means assertion is passing. Now, at this passage of the clock, okay, you'll find this blue square over there. It means that assertion is a star. So, at this passage of the clock, A is high. The next clock itself, B is high, right? Hence, the assertion is passing. Let's try to understand here. At this passage of the clock, A is high. The next clock only B is becoming high, hence the assertion is passing. Let's try to understand this condition, okay, while the assertion is failing. So when assertion fails, if B is becoming high after 3 clock cycles, okay. Let's try to understand this. At this passage of the clock, A is high. In the next clock cycle, you can see B should be high for even in first clock cycle or second clock cycle or third clock cycle. Okay. So at this passage of the clock, A is high. In the next clock cycle, B is 0. In the next clock cycle, also B is 0. Okay. Hence, you will find the assertion is failing over. Right. So this is what the timing window we can define for our assertion. Okay. Let's try to analyze this once again. If A is high here, in the next clock cycle, B is low. So if you analyze the assertion after writing and running the code, you'll find the console result something like this. So you'll find the succeed message and failure messages like this in the console. Okay. Let's try to analyze this assertion once again. What we want, if A is high from the same clock cycle, B can be high within 1 to 3 clock cycles. Okay. So if you can see over here, A is high in the next clock cycle, meaning in the next 1 clock cycle B is high, hence the assertion is passing. Okay, let's try to analyze the failure case at this passage of the clock. Okay. Here you will find at this passage of the clock A is high. Okay. In the next passage of the clock, okay, B is low. In the next clock cycle, next second clock cycle, B is low. And the third clock cycle, okay, B is low over here. What we want, till the third clock cycle, B should be high, but here at the third clock cycle also B is low, and the assertion is passing, failing over here. Okay. So this is what the timing means. So for this same assertion, we can write using same cycle implication operator, meaning if A is high from the same clock cycle, B should be high within 1 to 3 clock cycles. So we can write hash 1 to 3, B should be high. And let's say if we want to use next cycle operator, next cycle implication operator, we can write the same assertion like this. In the property definition, P1, at every passage of the clock, if A is high, from the next clock cycle, B can be high 0 to 2 clock cycles, right? And if you analyze the waveform, you'll find the waveform same, okay, as we saw in the previous slide. And if you check the console result, you will find the same result for this assertion. Okay, for this two assertion, the result will be same. Okay, so this is what the concept of timing window in system Verilog assertion. So with this, I hope you have understood the concept of timing window, and also I hope you enjoyed this video. So thanks for watching this video. Thank you.